Okay, hi everyone. My name is Louis Ducaire. I'm the VP Marketing and General Manager here at AGT Robotics, based in Trois-Rivières, Quebec, Canada. Today we'll have another webinar featuring robotic welding for one of our customers here. And so basically we'll discuss a little bit about AGT, a few words on who we are, what we do, what are our standard line of products, explain to you what's that specific application, and then go directly to the demonstration where we'll have first a blank run and then welding demonstration. So a few words about AGT. We've been in business since 1992, and since day one we've been in the automation sector and the robotic sector. So we've done hundreds, if not thousands, of machines over the past 24 years. We have one of our major shareholder is Fonds Manufacturier du Québécois, which is part of which is sponsored by CDP Capital, a big firm, investment firm that has $250 billion of assets. I'm originally from the company Oris Integration. We were Vision Integrator, and we were acquired by AGT in 2010. Our focus right now is combining actually vision and robotics to tackle low volume, high mix applications. So basically where the standard robotics would stop, that's where we start for impressive solutions. Today, you'll see a solution with a pretty standard robotic solution a little later. So a few words about our standard line of products. We've developed that starting in 2010. So we have the Beammaster Fit and Weld. It's a 3-robot, 8 3D scanners, 2-line solution to automatically scan the parts, pick them, position them, tack them, and then eventually weld them. All of that fully automatically from a few clicks from the CAD. His little brother, the Beammaster Weld, is a smaller system, a 1-robot with 4 rotators system to tackle the same application, so the same structural steel beam assemblies, but on the welding side only. Third product, Gouge Master. It's a portable unit featuring a robot and a plasma source for gouging. Plasma gouging application to prepare plates and parts for welding. Part of our business also is to develop and build and install custom solutions, so custom equipment based on the customer needs. We classify them in 3 main levels. First level, hard automation. For us, hard automation means that it does not include a robot, but it's a dedicated automation system, truly effective, and sometimes that can bring you very fast payback. The con side about that is it's less flexible if your parts would change over time, or if you have a high variety of parts. If you want more flexibility, then you go to the second level, which is robots. So a robotic system, whether it's a robot on rail, robot using Ferris wheel, different positioners, robotic systems are very repeatable and can tackle many different applications. You'll see it in a few slides. Third level is adding intelligence, vision, and software suite, software programs around the robotic solutions. And we have a patented solution that we call the SLT, self-learning technology, that basically enables the robot to auto-program itself. So if you have unique parts, really small batch production, this is a great solution and a unique solution, since all the robot movements that would usually need to be programmed by a robotic technician, whether it's with the teach pendant or offline program, well, you don't have to do that with SLT. You can go directly from point cloud, a 3D image, or CAD information directly in the robot and directly in production mode. Speaking also about custom solutions, people sometimes approach us and say, yes, but my part is huge. I have small parts, I have long parts, there's different application, different process. So basically, we are specialists at AGT to combine experts into a single room and basically work out a solution that would fit your needs. Whether it's you will have requirements on speed, on flexibility, on cost. So we work on different aspects and different solutions to bring you the best value and to bring automation in your plan. So you see here a few examples on robot on rail, robot on turntables, different positioners, and so on. So whether we have to move the robot or the parts or both, there's many solutions available. Process we master, basically all the processes around involved in the metallic industry. So first of all, assembly. We have also cutting, whether it's laser cutting, plasma cutting. If we cut in some situation, the process will need a grinding pass to finish, to have a better surface finish at the end. Of course, welding, which is the focus today, and inspection. So inspection, sometimes it's for quality purposes at the end of the process, but it's even more useful when you add inspection throughout the process, so you can validate each step and prevent adding value to if a certain step has been defective. So you can detect defects, but also you can also just specify or characterize the part so the next process is adapts itself to different tolerances that were just scanned or quantified or evaluated. Of course, we have other process like painting, sandblasting, shot peening, where we will partner with other integrators, other partners, other suppliers, or other specialists to provide a turnkey solution. So on the configuration side, we've split that into three different sections: the mechanical aspect of it, the programming, and the compensation. So on a mechanical aspect, that's a simplified way of showing it, but you can have a robot, static robot with a few positioners in front of them, so static robot. We can put the robot on a rail, and then you can basically travel almost as long as you want. It's very useful for many applications. Actually, the applications you'll see today includes a robot on rail. And the third mechanical setup is the robot mounted on a gantry. So you add sometimes 2, 3, even 4 axes to basically tackle applications where you have long and large parts. On the programming side, there's 3 ways of programming. The first way, the most standard one, is using the teach pendant. That comes with a robot, and basically any robotic technician can use it, or anybody at your place can use the teach pendant to program the robot. Second way of doing it is using an offline programming software, so OLP, offline programming. The great advantage of using a software like that is that you can program the next part or the next parts in the office while the machine is actually running on another production. So you don't take machine time to program your next pieces. The third option basically is not the program. So by using the SLT module, basically what it does is that you will program, you will go from a CAD or a point cloud and directly, the software will automatically take that information and generate all the robotic movements automatically, and thus go to production much more fast. On the compensation side, once again, 3 categories. the no compensation. So if you have a jig or a part that is very specific and very precise in its tolerances, maybe you don't need to find the joint every time because it's so precise. So speed up the process by just going directly to welding. That's the case, what you'll see today. There's other techniques such as touch sensing or laser touch, where you will actually touch the base, the wall, and different features in order to relocate the joint and then compensate pre-learned program. And finally, we can use, and that's our forte at AGT, we can use many 3D scanners to make a complete 3D image or point cloud of the part to be processed, and then manage the compensation accordingly. So why robotic welding? The main reason are those 5. First reason, quality reason. So of course, if you use a robot that's very repeatable, it's like having your best welder on duty, fully attentive all the time. Productivity. Once again, the process won't be that much faster with a robot because the process will kind of be the bottleneck for it. However, arc-on time is where you'll get most out of a robot. So where a human or a manual welder can do between 10, 15, 20, if he's very good, % of his time actually welding, the robot can reach level at 50, 60, 70, depending on the mechanical setup and the buffer zones you can add to the system. Cost, of course, a single investment that you use on 1 shift or 2 shifts or 3 shifts is the same investment and can bring you quite fast payback. And labor shortage. Welders are more and more tough to find on the market. So by having a robot, you simplify that part of your operations. And of course, safety. The robot doesn't mind working around fumes, even manipulators to handle rotations and everything. So a complete automated system can bring great advantages on the safety side of it. Now, back to our specific application. So what you'll see today, if I do a general overview of the system, so you have the operator console with the teach pendant to operate the system. You have the robot controls that are hidden basically behind the white curtain, so behind the rail. And you have all the safety features, the laser curtains and the safety relays and everything to manage the robotic cell, so it can be can be accepted by the CSA norms here in Canada, and also the UL and CE norms in all around the world. Now, if we focus on the robotic system itself, the robot is a FANUC robot with a Lincoln Electric welding source. Everything is mounted so the source will follow the robot along with the wire itself. And we have headstock, tailstock kind of positioners that handles rotation on 360 degrees. We also have a clamping system with specific jigs to handle that specific part, so we can load it using a lift truck and then squeeze the part between the 2 positions. So how it works, so basically first the operator will put the part using a lift truck inside the positioners. He will use the button to clamp system together and then use the teach pendant to actually load the right program. So let's say this is part A. You will find program for part A, hit start, and then the rest is done completely automatic. That's what you'll see in a few minutes. Now what is, of course, once the system starts, the welding, positioning and the welding are done automatic. So a few words on what exactly is the purpose of that part. So this is a manufacturer here in Canada. So they manufacture parts for grain elevators. So this is a grain elevator. We'll zoom in on the section where the part we actually produce. So it's the top section. This is galvanized steel, and this is what you'll see in a few minutes. So a few technical words. So the system has about a footprint of 15 feet by 20 feet. And the maximum parts supported are 10-foot long pieces, and the maximum diameter of 72 inches. Of course, these are the limits and the requirements for this specific system and that specific customer. We could go longer. We can go add more weight, and so basically this could be customized to your specific application. So without just before going to the demo, a few things to remember on the benefits of the system. It's fast, secure, reliable, flexible, and very easy to operate, as you'll see. So we'll go on with the demonstration. So the first thing I will do is I will secure the part in place, and so basically the lift truck would go and position the part on so the system would be open like this. The lift truck would come up and position the part in it. Once the part is in position, just by pressing a button, there's an auto centering feature where the part is auto centered, so the robot can execute his schedule exactly at the right place. And then using the pitch pendant, we just select the right program and executes it. So what we'll see right now is just a blank run, so it won't weld, and then we will redo it with the welding activated. So let's start. So a few specs on the process itself. So the robot is featuring we're using a solid wire. We're using weaving in the process. It's a silicon bronze GMAW wire of 35 thou. And right now the joint you'll see is a lap joint, 1/4 of an inch. So that was the sequence. Now we'll redo it. Now activating the welding. Okay, so now it's time for question and answers. I think we had a few ones, but most of them we already prepared a few answers for general questions that usually people have. So one of the question you may have looking at this system is if we can do the same kind of system with cylindrical parts. The answer, of course, is yes. By using the headstock, tailstock that are linked to the controllers, the robot and the positioner can work in conjunction to actually work together to make very good quality and assure the right positioning. Another question that comes up is on the welding time. Typically, the welding time, as I explained earlier, the process itself, as you can see, is quite fast. It will be as fast probably as your best welder, but it's mostly on quality, and where you will save on time is mostly on arc on time. So the positioning of the part, the fact that the robot doesn't take any break, doesn't need to stretch or anything. So typical arc on time at manufacturing places for manual welders will be between 10, 15, 20% of the time they'll be actually welding. With a robot, with the right combination of configuration, positioners, and everything, you can reach 50, 60, 70 in some situation arc on time, and that's where you'll get the most of your payback. Last thing maybe to mention on this system is the second zone. So the system was already configured with additional security, so we can add a zone quite easily. So by extending the rail and extending the positioners, or adding a second set of positioners, that's something that's pretty easy to upgrade in the future. I think we have another question. Okay. We have a question on multipass. Typically, it's possible to use robot for multipass welding. It's pretty easy to get to 3 passes. So the root pass, you would use either a pre-programmed approach or a laser touch, or even you can scan the entire joint to position the part. And then the second and the third pass would be only using pre-programmed offset from the root pass. In some situation, we could go 4, 5, 6 additional passes. Then we would have to look at the situation more in detail to see what are the quality requirements. Because the more pass you do without actually rescanning, the further you'll get from your nominal, and it's very important to control all the passes to get good quality. Any other questions? Okay, so thanks a lot for that, for your attention while you were at lunch for most of you. So if you're interested in knowing more about our system, I invite you to contact us by email, by phone, or to visit our website, where there's many other webinars you can watch, many different videos, brochures, and information about systems we did in the past. So thank you once again. And for those of you who are really interested in having the French version, we'll do it in about 20 minutes. All right.